Third-party software is going to provide you with some class definitions. These are basically header files, and if you want to use these objects, you just you include those header files in your source code. And it also provides libraries. So Professor Sutherland mentioned libraries, and they're sort of this in-between. They're not executables, but they're not source code. They're just a bunch of compiled code that you can basically just stick into your executable at the points where it's needed. So the compiler needs to know about these libraries, but your source code only needs to know about header files. Okay? So the kind of typical directory structure for organizing these things, and if you download, any kind of third-party package, you'll probably see these. There's the source, src directory, which contains the source code. There's the include directory, which contains all of your header files. And then there's the lib directory, and that contains libraries. So that, for a third-party package, it'll provide all kinds of libraries so that you can use the code that somebody else wrote, and you don't necessarily need to look through that source code and understand it. Okay. So what we're going to do is, we're going to actually create a library. So our first step is to compile our object code. So I'm just going to use the same Hello World program, or not the Hello World program, the simple A class and driver that we've been using. So we're going to compile this object code for class A. Then we're going to put the object code into a library instead of linking it to an executable. So this is just going to create a standalone file, lib class A, or whatever we want to call it. And then the last step is to compile our driver, and rather than telling it, hey, here's where the source code that's already compiled is sitting, we're going to link to a library instead. So before, when we actually gave the command to compile our driver file, we said, we gave this argument a.o. And the reason we had to do that was because driver used this A class. So instead of specifying a.o, we're just going to link to the library that contains class A. Okay, so our first step is, just like we did before, we're going to compile this object, and this is going to create a.o. Our second step is actually creating the library. So we're using something called ARRS, and this is going to take, so our first argument it's going to take is the name of the library we want to create. The second argument is all the .o files we want to put into that. So if we had, let's say, a class A, B, C, D, E, F, G, then we could put all of those here. We could put A.o, B.o, C.o, and it would put all those classes into one library. So just one thing to notice is this prefix lib. So as Professor Sutherland mentioned, that's kind of the norm for naming libraries. And then our last step is to compile our driver and link to this library. So there's a couple things to notice here that are different. The first is this -L. So just the same way that we had to tell the compiler where to look for header files, we also have to tell it where to look for library files. And that's what the -L is for. And not only do we have to tell it where to look for libraries, but we have to tell it what library to look for. Because a lot of times in this lib folder, in the folder that contains the libraries for any kind of third-party package, you're going to see maybe a dozen different libraries, and you don't need all of those libraries, so you just specify which ones you need. And the -l, the suffix is going to be the name of the library without the lib. Okay? So let's actually do this. And you can follow along. So the source code is, the same source code that's on the website. Okay. So I've got this directory structure: include, lib, and source. So in the source directory, I've got my source code, my .cc files. So my first step is to compile my object. And so instead of doing -I dot, my header file is now contained in the include directory, so I need to have this include instead. My next step is to create this library. And I'm just going to call it lib class A. And the suffix .a is particular to libraries. And then I'm going to say what I want to put in it. So if I run an ls, I can see this a.o in my current directory. Okay, so I've created my library. When I look inside the library directory, I see I've got my libclass.a. And then my last step is to compile my driver. I just do this the same way as before, except now I do -L, and I tell it where my libraries are, and -l, and the name of the library I want to use. And I also have to include the header, give it the include directories. Okay. And so now I have my driver executable. And so it works transparently. It doesn't need to, so I don't need the source code for the A class. All I need is this library. And all of the way that works is hidden to me, and it doesn't need to be, I don't need the source code to do that. Okay? Okay, so there's all these different levels that you can go into with libraries. You can just sort of disappear down a rabbit hole and explore the assembly code and pull apart the structure of these programs if you want to. But that's kind of computer engineering stuff. But one thing I do want to do is I want to disassemble this library and show you what's inside the library. And this is really simple to do. What we need is a tool on Mac called OTool, or on Linux you can use objdump, objdump. Okay. So I've got my library, libclass.a. And I can give it two options, this TV option. And what that's going to do is it's going to disassemble this library and show me what's inside of it. And if you're curious about OTool, you can just type man OTool and it'll give you all kinds of options. But what you're going to see is a bunch of calls to all of these different assembly instructions. So this looks very similar to what we saw when we ran disassemble in GDB. Okay. Now just to take this one step further, we can open up driver.x in GDB and do the same thing we did before. Except instead of disassembling main, let's look at this echo function, this function that'll actually print, x equals 5. Okay, so this echo function is just using, the same thing we saw before. It's saying printf, x, and x is equal to 5. So then there's all these assembly instructions. Okay, so the order is push, move, push, push, sub, call. So now let's look through the library. And this block right here has the same order of instructions. Push, move, push, push, sub, call. And that's in the library. So basically, this library is feeding assembly code to our executable. We don't need to know about the source code because this library contains these assembly language instructions. Okay. And you can do the same thing with obj dump using the -d flag or otool-tv. So those will do the same thing. It'll disassemble the library. Okay. So that's about it. Libraries are basically just storage containers for computer code. So they contain assembly code, and you can think of the compilers as saying, when you link to this library, it'll just take these chunks of code and stick them in your code wherever you need it. Okay, so we covered basics and terminology. We talked about what compilers are, machine versus human languages. We talked about creating and building software and the different tiers of small projects, medium projects, big projects. And then we talked about libraries and how we can use these third-party projects. Yeah. Okay, so I've got some more information on building software. You can just type man GCC or G++, and that'll give you a lot of information on a whole bunch of different compiler options. So I just gave you a couple, this -G and -O, 1, 2, and 3, but there's actually a whole, you could write a book on this. You can use Google, you can just type, compiling GCC or G++, and that'll return a bunch of useful information. There's also an ebook that gives you an introduction to the compiler collection. And then a Wikipedia article for the GNU compiler collection gives you lots of external links. Makefiles, same thing there. There's a Makefile tutorials. If you Google Makefile tutorial, you'll get like 50 different Makefile tutorials. And then libraries. You can just Google Unix libraries and get all kinds of useful information. The Wikipedia article for library will take you to libraries, not like computer libraries, but normal libraries. So you have to add computing. And then there's an article I found that was useful on working with Unix libraries. And then a summary of all the commands we saw today. And those are all on the board. Yeah, so originally I was just going to have us take a break, but is anybody interested in building tab props and some of the programs related to that?
Tab props, yes.
Okay. So yeah, so if you're interested and you want to stick around, then feel free. So what we'll do is just make HDF5. We've already done CMake, and then we'll also install Cantera, and then we'll use all three of these to link to tab props and build tab props.
What are tab props used for?
Yeah, okay, so that's a great question. Tab props is a code that tabulates properties for combustion. So it uses HDF5 as a data storage format. It uses CMake as a build system, and then Cantera is a combustion, like a chemical equilibrium calculator or a chemical kinetics calculator. And so tab props uses Cantera or drives Cantera to generate all this data, and then it stores it in HDF5 files so that you can tabulate chemistry offline and then use it in simulations. So if anybody's interested, then stick around.